Okay, today, or for this video, we're going to talk about the Pythagorean theorem, which is one of the most famous theorems ever in the history. I'm sure you've heard of it. So before we start, I want you to look at this right triangle. So a couple things about the Pythagorean theorem. One, true for right triangles. Okay, so only for right triangles are we going to use this. Next, if you look at this, A and B represent the legs. And those can be interchanged. It doesn't matter which one you say A and which one you say is B. However, C has to be the hypotenuse. So for all, in any textbook you ever look at, anything you look at online, the Pythagorean theorem will always say A squared plus B squared equals C squared. Okay? And for this, A and B are always the legs, right? And addition's associative, so it doesn't matter which order it goes in. And C is always the hypotenuse. Okay, so now, that's all it is. The square of these two legs equals the hypotenuse. Let me give you a little more background. Okay, so if I have my right triangle, right, geometrically, right, if you're going to draw it, what it means is that if I drew a square off of here, and a square, if I drew a square off of every side of that triangle, right, the area of this is B squared, the area of this square is A squared, and the area of this is C squared, right? That's what squared means. The area of square with a specific side length, right? So what this means is that if I took this square and this square, I could fit them perfectly, the areas, into this square. And later on this year, you're going to look at some really cool proofs of the Pythagorean theorem. Just so you know, there's hundreds of different ways to prove the Pythagorean theorem. Okay, so now let's just kind of work a couple examples. So if I have a right triangle, and I say, hey, this is 5 and this is 7, what's that hypotenuse? I'm going to say 5 squared plus 7 squared equals C squared, right? The hypotenuse is what we're looking for, so that's C squared. So I'm going to say, 25 plus 49 is C squared. If I add those up, I get, 74 is equal to C squared. So C is equal to the square root of 74. 74 as a square root cannot really be reduced. But if you would like to use it, if you would like to just evaluate it, you can always evaluate it in your calculator, in which case it's 8.6. Okay, so you need to really understand your context. If you're looking for an exact answer, this is an exact answer. Square root of 74. That can't be simplified. That radical can't be simplified. If you're going to use this number later on, if this is part of a bigger problem, then you may need to approximate. Okay, let's look. Okay, so again, I have a right triangle. Let's say this is 3, this is 8, and I want to find out what that is. Okay, why don't you pause the video and try and figure that out? Okay, so if you do this, this is a leg. The unknown is a leg, so let's call it B. Doesn't matter, A or B. 3 squared plus B squared is equal to 8 squared. So 9 plus B squared equals 64. So B squared is equal to 55. So B is equal to the square root of 55. Okay? So those are the two in this introductory video. Either you don't know the hypotenuse or you don't know a leg, okay? In the next video, we'll talk about some other tangents and other things that go along with the Pythagorean theorem.